interesting stuff that's going on here. Okay, so those are the first two or three, I guess, points that are key. What else do you think might be an interesting point on a parabola? Because there's one other thing that I would sort of find interesting to myself. You're not? What else could be interesting on that graph? Did anyone else see anything interesting? Yeah. Well, slope, yes, slope sort of, okay. The thing about the slope's going to be changing all the way through, okay. So that is interesting because when you get to calculus in grade 12, that's what the whole year is on, okay. But for grade 10, there's one other point that might be interesting. I don't see anything else that's interesting. Okay, if nobody says yes, I will demonstrate. Let's say I take Spider-Man. I'm going to throw him in the air. What might be interesting about this throw? What might be an interesting highest point? Good, okay. So as far as this is going to be the lowest point in this case, okay? So the highest or lowest point is totally going to be interesting. So this one we're going to call the vertex, will be the last one. Okay, so we're going to say the vertex it's going to be the highest or lowest, so we're going to say the midpoint of the graph.
Is this the third point?
Yes. It's actually the fourth, I guess, technically. Because I call it the 4 points because the x-intercept, there's 2 of them, right? So there's 2 x-intercepts, right? So that sort of counts as 2. And then the vertex and the y-intercept, those are the 4 key ones, okay? So the vertex is going to be the midpoint of the graph. Again, if you take a look, there's a mirror image on both sides, right? If you go back to our equation that we did here, right, this is going to be our vertex. Both arms are identical on both sides. Okay? The midpoint of the graph, it's also going to be also the highest or lowest point. And that's a big deal. Like the vertex is really, really important. All right. We're going to deal with all sorts of applications of parabolas. Okay, so vertex is really, really key. Okay, I'm going to get to a little bit of algebra now. I've done enough definitions for one day. Okay, so those 4 words we've been using lots. It's very important to keep them clear. And I'm glad you guys, we did that warm-up unit. So we do with x and y-intercept are. That's really going to help us, okay? So just a reminder again, y-intercept is standing by x equals 0. X-intercepts is y equals 0. And factoring, we'll get to factoring a little later in the week. And vertex is going to be the middle of the roots. And we'll find, or so it's going to be the middle of the graph. We'll find that out later on, okay? And again, this is just a little mini graph. You can put this either on your nice graph or just draw a little mini sketch. Okay, those are the key points for parabola. I will talk about all 4 of those things tons and tons and tons. Good? That's all right? Too excited?
There's also going to be 2 x-intercepts and 1 y.
No.
No.
Okay, just right for a second, I'm going to show you why here, okay? Okay, so Natalie asked a wonderful question. I didn't actually want to go here today, but I'm going to. Okay, so Natalie asked a good question. She said, Mr. Sadler, always going to be 2 x-intercepts and 1 y-intercept. Okay, so this is like the general case for a parabola like that where there's 2. All right? Another one that could work is this. Okay, that would also have 2 x-intercepts. Can somebody think of a scenario where there would be no x-intercepts? Sideways isn't a problem. Good thinking though. Sideways probably doesn't work. Anna, go ahead. Yeah. So the reason I always give my example of my daughter swinging. Okay, I love my daughter very, very much. This is her on the swing. Okay, so she's swinging on a beautiful parabola every day. I think that I'm such a math geek. Okay, she's on the parabola making equations in my head. Okay, all that means there is that her feet are not hitting the ground. Okay, that's a good thing. Okay, like she's she's not getting kneecapped on the swing. Okay, for that, that's fine. That's fine for that to work. There's no issue with that. Okay, or again, my other thing I think of, and my wife really did. This isn't a joke. This is serious. Like when I go to the movies with my wife, she doesn't go to see Spider-Man with me anymore because Spider-Man's on the left. Like, oh, look at that parabola, and she doesn't. That's cool. You guys ever see Avengers where Iron Man puts a mask on? And like all the trigonometry comes in there, and they start doing angles and speeds, and I'm just like going, oh, look at that, look at that. And my wife's like, yeah, that's not interesting at all. So, but anyway, the point is, this is Spider-Man on his web there, okay? All that means is that he's not crashing into the concrete when he's swinging. There's no problem with that, right? Can anyone think of when there would only be one x-intercept? When could there be one x-intercept? Yeah, Nick, go ahead. Good, when the vertex is right on here. So imagine here, this is somebody shooting a basketball or a volleyball, okay? If I throw the pen, I'm not going to do it, and it just barely touches the ceiling, okay, right, that would be one x-intercept. So the highest point is right on the line, and that's okay too. So that would be, again, if you're on your swing, and you just do this, just where it just barely touches the ground, okay? So it is possible to have 2 or 1 or 0. In about 90% of the cases, there's going to be 2. Okay, so that's why I put it on there as 2 x-intercepts, all right? But it's possible to have not. Okay, let's get to a little bit of algebra today if we can. Converting factored form to standard form. I put in bracket foil. Foiling. Because when you look back at the end of the year, you'll say, oh yeah, foiling, I got it. Okay, you don't remember the title. Factored form to standard form. Here we go, example 1. Excuse me. Okay, so this is like the other distributive stuff we did yesterday, right? We're going to have to multiply everything outside the brackets by everything inside the brackets. What makes this question more awesome than what we did in the board yesterday? What's up? Yeah, there's 2 sets of brackets, okay? So this is like a binomial by a binomial. This is tricky. So what we want to do for distributive law is we want to multiply everything on the left bracket by everything in the right. And this is called foiling. Okay, I don't want you to think of it, because the textbook tells me I should use foil, I'm going to call it foil. But really what you want to think is that 2x multiplies by x plus 3. And then that 1 multiplies by x plus 3. The foil is the official acronym for this. Okay, what foil means is first, outside, inside, last. So it means in order to multiply these, you're going to multiply the first term in each bracket, then you're going to multiply the outside ones, then you're going to multiply the inside ones, and you're going to multiply the last ones. I do not like that acronym, although I'll use it, I'll say foil. But basically what you're thinking is the 2x hits both the x and the 3, and then the 1 hits the x and the 3. I will show you how it's done. This is really easy once you get it down. Okay. So, what I'm going to do is I'm going to use nice big arrows. So I'm going to make sure that I multiply the 2x by both things. So can someone be brave? Where did I stop it? Do we use Spider-Man? Where's Spider-Man? Spider-Man's there. I'm going to pass on you because I know you know how to do this.
He's right here.
Oh, beautiful. Karina, what is 2x times x, please, going to be?
2x squared.
2x squared, good. All right. Okay, then what I'm going to do, Megan, is going to multiply the 2x times the 3. So what's 2x? 6. 6 what? 6x, good. Now I know I'm going through this quick, I'm going to try and slow down. The reason the first one was 2x squared was you multiply the variables and the coefficients. So 2 times 1 is just 2. X times x is x squared. For the second one, 2 times 3 is 6. X times nothing is just x. All right, Calvin, what's 1 times x, please? Good. And finally, Hannah, what's 1 times 3, please? Good. Okay, because I'm a math teacher, I always call this, I always do a little doodle at this time. You don't have to. That guy called the foil bird. The reason I draw that guy in there is because when I was first started teaching, I was teaching, there was 3M was the course, so it's for kids that get like 50s in this course and really probably aren't going to end up being mathematicians. So this guy was an artist and he hated math. So I used to make kids put the homework up on the board. And what he would do was every single question he would draw this guy and he'd be like walking on a polynomial city, draw this giant bird terrorizing everything. I thought, well, that's sort of cool. So that's in there. And I also have a bird at the back with a foil bird there as well. Now, enough about foil birds right now. Another question?
Okay, so the 2x times x, that's the first.
Yes.
And then 2x times 3.
That's your outside, yeah.
And then the 1 times the x is the
Inside, yeah.
And then 3 times.
Yeah. Good. Okay, now Luke, I'm going to pick on you. I'm not happy with this answer. What can I do to make this look nicer, please?
2x squared is 7x plus 2.
Good. Because we did 6 plus 1, right? So 6x plus 1x. It's like there's an invisible 1 there. Okay, so what you're doing is here, this is called expanding, foiling, whatever you want to call it. Okay, so it's taking the equation from factored form, which you use to find x-intercepts, to standard form, which you can use to find the vertex and the y-intercept. All right, we're going to go backwards here too in the next few days. All right, does that sort of make sense what happened? I want you guys to try one for me right now, and you guys, I'll take it up here in a minute, okay? Number 2, or letter B, you don't have to draw the bird, by the way. I had a class, or not, it's when I teach applied, we do the same lesson, but it's later on in the course. And like the kids that don't like math, they'll just spend like hours on this foil bird during their test. They'll answer 3 questions, but they'll have one guy have like a beautiful, he's going to be a tattoo artist, I think, when he grows up, okay? He's like a beautiful, intricate foil bird on his page, but he got 3 out of 20 on the test, okay? So please don't do that, okay? B says 3x plus 2x plus 4. Okay. Oh, excuse me. All right. So I'm going to pause in the video. Stop, I guess. Okay, so